Hi there, it's Matt here, and welcome back to the show, and welcome back to another of the guest episodes. My guest today is the fantastic Aric Prather. Aric, a PhD, wonderful guy. He is a leading expert in sleep science and behavioral health. He is serving as professor of psychiatry and behavioral sciences at the University of California, San Francisco, just across the bay from me here at the University of California, Berkeley. He is the director of the UCSF Center for Health and Community, and he co-directs the UCSF Aging, Metabolism, and Emotion Center. His research has, in my mind, it's significantly advanced our understanding of how sleep impacts physical health, immunity, as well as emotional well-being, meaning that he's just one of those people who has plurality. He just seems to be able to annoyingly do everything. Aric's work, it's frequently featured in high-impact journals and media outlets like the New York Times and NPR. I should also note, by the way, he's written a fantastic book. His fantastic new book, The Sleep Prescription, 7 Days to Unlocking Your Best Rest. You absolutely need to go out and check it out. It's a wonderfully informative, elegantly written in terms of digestible bite-sized chunks, 7-day guide, and not just 7-day guide, but from morning to evening on each one of those days guide. And he has just an exceptional ability to translate complex science into actionable strategies. It's not just that you understand the science, you understand what to do with it. And I think his insights have really reshaped how we view and manage sleep health in both clinical and everyday settings. So without further ado, Aric, welcome to the show. And I'll first ask you, maybe just give some background in addition to that. And don't be shy, don't be modest, as to what you do, but also just how did you get into sleep science?
Yeah, thank you for having me. It feels like I kind of fell into this and I'm just really grateful for the opportunity to do this work in sleep. I did my PhD at the University of Pittsburgh that has a kind of a really big, well-renowned sleep and circadian science program. And so I kind of soaked up some of that stuff. A mentor of mine, Martika Hall, actually was a big proponent of sleep and how it's related to health. And so I was really fortunate as part of my training to begin to integrate measures of sleep into the work that we were already doing in the field of psychoneuroimmunology, which is kind of the study of the behavioral and psychological and biological factors that drive immune function. And then as a clinical psychologist, you have to do like a 1-year internship where you just kind of see patients and get that kind of training. I did that at Duke University Medical Center. And I got to learn from one of the pioneers in cognitive behavioral therapy for insomnia, Jack Ettinger, and his colleague, Andrew Crystal. It was there that I really got this opportunity to see, gosh, sleep is just an incredible leverage point for improving health. I was lucky enough to go to UCSF and be able to set up my own research program and been able to work with tons of really smart folks and do work spanning in laboratory work, trying to understand what happens when people don't get sleep and how that changes their emotions and how they deal with stress, but also testing some interventions to try to improve sleep and how that might have downstream effects on their biology. I also have the great fortune of helping run a insomnia clinic in San Francisco, getting to see the research translate into practice and how I can get an opportunity to get people's sleep back on track. And that's been incredibly meaningful for me.
And I think that makes all the difference. I know that we were speaking just before we started recording about how it feels to be on the front lines, boots in the trenches. It's one thing to do in the hallowed halls of academe, to do one's research and publish, but it's a very different thing to then be at the forefront and see patients, see what they're struggling with. Doesn't it just bring your sense back down to earth in terms of what it means not to sleep as a human being?
Absolutely. And I mean, I also think it helps shape my thinking around the high impact research questions because people come into the clinic and they really want to know, and they're really worried about what is going to happen if I don't get sleep, concerns about neurodegenerative disease, susceptibility to infectious illness. What is driving that? It's been this nice back and forth to use this research to help educate and kind of move the field forward, but also as you said, kind of remain grounded and understanding that we can talk about sleep health at the population level. We can talk about innovative interventions, but at the end of the day, there's a person sitting in front of you, or
Yeah.
me now on Zoom,
Yep.
nevertheless, that really is searching for something, and the opportunity to be able to impart these skills. I'm eternally grateful for this opportunity.
Well, they are, I'm sure, of your help too. And today's episode, I think what I would love to do is just drill down into one of the things that you mentioned there, what seems to be an incredibly intimate relationship between our sleep health and our immune health. And that concern that patients have that you described, what's going to happen to my immune system because I'm not sleeping well? I'm worried. And when I was back in the UK, back as a young lad at university at the Queen's Medical Centre, sometimes I'd be speaking with my mum and I'd mention I was sick again and yet another cold. And she would always ask me, she'd say, "You do seem to be getting sick a lot. Are you sleeping enough?" And I sense her intuition was right, but you tell me at the sort of high contour, 30,000 foot view, what is the association between sickness and sleep?
Yeah, it's amazing. It's one of those things that I feel like the work that we do and others that are in this field do is so compelling. And then I meet someone's parent and they're like, "Well, didn't we already know this? What are you doing with your time?" The government paid how much for that? And it's true because we have this intuition about sleep and our immune health, right? Like when we get sick, what is one of the things that we first need to feel like we need to do is sleep more, to conserve energy, to build up the energy to have that fever. And in the same way, like when we are kind of all gas, no break, burning the midnight oil, not getting the sleep, inevitably people end up getting sick. And it's been the work that we've been doing to really try to understand, like, is there some real science there? And what are the underlying mechanisms through which sleep, which is clearly so powerful for our health, how is it impacting aspects of our immune system that have real public health relevance? And we've kind of gone in two directions, and maybe we'll talk about both of those today around susceptibility to infectious illness, right? So kind of viruses, and then the tendency for people who don't get enough sleep to actually create more inflammation in their body, which is another aspect of the immune system that has been associated and part of the pathway to a whole host of age-related conditions like cardiovascular disease and the like. So yeah, I mean, there's clearly this bidirectional relationship. Sleep impacts our immune system, and then of course our immune system gets activated and impacts our sleep.
Before we get into the science of that, I wonder if we should just do a quick primer because the immune system itself, I think, is if I wasn't in brain science and I had to look at another major system within the human being, it would be the immune system. I think it's fascinating. It is incredibly complicated, but I know you're not an immunologist by trade, but can you give us a bit of a systems 101, just a quick introduction about the immune system, its primary components, before we perhaps jump into what the underlying mechanisms are between sleep and the susceptibility to infectious illness? That's such an unfair question, but could you just give us the 101, the skinny on the immune system?
Yeah. I mean, it's obviously important to at least have this background context. And I think it's interesting that you bring up the brain, right? Because we used to think the brain is this kind of privileged organ, but now there's such an interplay between the immune system and the brain. So I think as we continue, we'll both need to increase our knowledge about all of these things because they're so interrelated. But yeah, I mean, the immune system in general is very orchestrated system. But when we think about it, when we talk about it, when immunologists even talk about it, they really kind of break it up into two distinct arms. The first arm is what's called the innate immune system, or the innate arm. And this is one that is fast, it's kind of always on, it doesn't change or learn, it's really at the ready. This is made up of immune cells like monocytes, which become macrophages, these kind of eating cells, natural killer cells, granulocytes like neutrophils and eosinophils and basophils. And then in the brain, microglial cells, dendritic cells, all fall in this. I think of them as kind of sentinels waiting for things to happen and then acting. The other arm, in contrast, is what's called the adaptive arm or adaptive immunity. And it's more slower acting, but also learns over time. It creates memory as we're exposed to things in our environment. These are made up of cells like B cells, which are the cells that create, say, antigen-specific antibodies like to the flu vaccine or to the COVID-19 vaccine. And then T cells, most notably helper T cells that serve as kind of the quarterback of what the immune system should be doing, but then also cytotoxic T cells. These are cells that can kill things to ensure that you're safe. And on these cells, these B cells and T cells, they have specific receptors on them that are specific to unique antigens. So we create a repertoire
And an
for all
antigen is
an
just,
antigen, like an invader of sorts, like a virus or
yeah.
part of a virus or something like that, right? Where we have a repertoire of receptors for all of those things, but they're unique so that we can kind of cover everything. And when they're activated, it actually sets the immune system in response. I'm saying these individual pieces, but it's very orchestrated. All these parts, everybody has a part to play here. And where this all lives is, in our bloodstream, but also in lymphoid organs, or like the barracks where immune cells will spend a lot of their time. And so like the primary ones are things like the thymus or the bone marrow, but there's also like secondary ones that we know well, our lymph nodes, for instance, or our spleen or the mucosa. The final thing that I think is important to think about when we think about the immune system is how the communication happens. So cells can kind of interact with one another by touching, like a T cell might act on a B cell to get it to do its next thing. But also there's like really important chemical mediators like chemokines or cytokines. And these are chemical messengers. They tell the immune system what to do, how to migrate to, say, a place of injury, if, say, you get a wound. And there are really important ones that we know about, and this is relevant to sleep, but also to kind of things like infection, that activate this inflammatory cascade. So this inflammation that creates pain or heat or redness on the skin if you have a wound, but at low systemic levels can also be associated with increased risk for these age-related conditions. And so ones that often come up, but also seem to play a role in sleep and sleep regulation, are things like interleukin 1, also known as IL-1 or IL-1 beta, IL-6, which is one that people often hear about, and then tumor necrosis factor alpha, which is another pro-inflammatory cytokine that is part of this cluster of cytokines that are associated with inflammation.
A long-standing partner of today's podcast is Element, spelled L-M-N-T. Element is a sugar-free electrolyte drink mix, and for me, it was the sugar-free part that made me start using it a while back. I buy my own supply just to stay objective, and beyond having electrolytes in the right balance, the other reason I'm a fan of Element is that it's scientific. If you look up the people who created the company, you'll find some pretty heavy-hitting physiology, biochemistry, and pharmacology expertise that's baked into the product. And again, all of that comes without any sugar. I also wanted to share that Element's newest limited time flavor, lemonade salt, is squeezing onto the scene Tuesday, May 20th. Anyway, I should note that this is a limited time flavor, so if you like the sound of lemon-flavored electrolyte goodness, grab some now. Happily, I badgered them, and they have agreed to give you fine folks a free 8-count sample pack with any purchase of Element if you use the link lmnt.com/MATTWALKER. So for free product with your purchase, just visit lmnt.com/MattWalker. And as I said, you'll get some free product. And so in that system, in some ways, it seems as though we've got preloaded things that can just respond very quickly. And then there are a collection of other things that surround that. But one of the core other components is this notion of a memory-based system that we forget about, which is that the immune system can learn, and then it keeps this sort of back catalog of all that it's learned, such that if it faces it again, you don't have to necessarily go through the learning process. Is that one way to think about it too?
Yeah, that's absolutely right. And gosh, that's a great way to talk about it. That's basically the way in which vaccines work, right? So if you take the COVID-19 vaccination, there was a part of the virus for people who had never been exposed, never was infected with SARS-CoV-2 virus. They get the vaccine it creates this strong immune response, but also the creation of memory B and T cells that live on along with the antibodies that were released by those B cells, so that if you're ever exposed to that virus, your body will react more rapidly and kind of build up the army to rid yourself of the virus and recover. And it would be much more quickly than it had if you had never been exposed before. That's a fundamental piece of how vaccines are effective.
Which is amazing, isn't it? That something we think is very cellular, very biological, actually has a learning system and a memory system. And its memory system can really go back an entire lifetime in some ways. Often we only need to get vaccinated once based on certain things. And there it is for one's rest of life. But before I keep harping on about my love of the immune system, I want to bring it back to sleep and tell me a little bit about the evidence linking sleep and perhaps more specifically a lack thereof to infectious illness, and how have we moved from essentially very basic epidemiological studies, which are we see an association, short sleep equals this type of infection rate, to perhaps more prospective studies that lead us to a path of causation rather than simply correlation.
Yeah, I mean, that is the transition that we've been trying to move towards. And it's really in creating the empirical base of what your mom knew. And so, what does that look like? For most studies, we start with animal work, and there have been some really elegant early animal studies where animals have been deprived of sleep and, unfortunately, they don't survive. And when looking more carefully at what's going on, it's the breakdown of the immune system that it ends up leading to death and the unregulated septicemia that occurs. But then in humans, we have started with population-based studies, kind of the classic epidemiology, and there is a good evidence base for this. And it's actually how our lab does a lot of our work. We take a step back and look at the population level associations to see if there's a signal, if there's something that might have real public health relevance, because we're seeing it across this large swath of the population. And then we try to model it more carefully in the laboratory to try to understand that causal path. And so there thankfully are a number of large data sets that are publicly available here in the US. And so we've done this. So one example would be the National Health Interview Survey, which is a survey that's given out each year to a new set of people. And they had asked questions about how much sleep people got and their work schedule and things like that. And then just the simple question of, in the past 2 weeks, have you experienced a head or chest cold, right? So it's not the greatest of measurement, but when you scale it up, you might be able to see a signal there. And so in this case, we looked at 2 separate years where these questions were both asked. And in 60,000 people and weighted for the population, we found that after adjusting for a whole host of things that we think might contribute to head or chest colds or increase the likelihood of those, we found that people that were on the shorter side of sleep compared to people who slept 7 or 8 hours, people who slept 5 or fewer hours per night based on this just questionnaire were about 44% more likely to have had a head or chest cold in the preceding 2 weeks. And similarly, we saw an association with people that were rotating shift workers, people that are often starved for sleep because of circumstances related to their occupational opportunities. And so in both cases, we see that short sleep is associated with that. And we've kind of seen this in multiple cross-sectional studies up to this point. And then there have been some prospective studies. So Sanjay Patel, over 10 years ago, published data from the Nurses' Health Study, which is this long-standing study of nurses, mostly at Harvard and elsewhere, and found that individuals that were short sleepers were more likely to have incident pneumonia. So this wasn't correlational data, this was cross-sectional data. It was over time, they were more likely to actually have verified pneumonia. Thankfully, pneumonia isn't something that happens too often. And so it took a large data set to actually identify enough cases, but it did provide some of this prospective evidence that we're interested in. But then, there are obviously lots of limitations to these types of observational studies, right? When we talk about sleep and infectious illness, it could be that exposure is so important. When people ask, I do all these talks about sleep and immune system, and they say, what's the best way to make sure I don't get sick? And my answer inevitably is always, well, exposure is the worst thing you can do. Try not to get exposed to a virus. That will put you in good hands. And so this is the same issue with the limitations of these observational or cross-sectional studies is, it could be that people who sleep less are, say, out more, they're around more people. And then because they have more time, they're more likely to be exposed to viruses. And so we tried to address this in a more compelling study in the laboratory.
Maybe I can dig a little deeper then, because if you reverse the tables on the associations, which is insufficient sleep, short sleep, people sleeping typically less than 6 hours, leads to this almost vulnerability of your immune system because the walls are down and the invaders can come in. Conversely, then, what is it about sleep when we do get it that then seems to provide this cloak of almost invincibility? What is happening to our immune system and our immune weaponry in the arsenal of that system? Do we have any sense of what it is that sleep does? Is it just that more wakefulness is bad and it's just the absence of wakefulness that restores the immune system? Or is there something special about sleep that really does help us with restocking the immune system and maybe even sensitizing it? I don't know.
It's a great question. It is one that we really need to do a better job of trying to understand exactly what it is that's so magical about sleep as it relates to the immune system, but also to other aspects of our physiology. Primarily, the work has been done in the context of experimental designs where one group is deprived of sleep and the other group is allowed to sleep. And then we serially measure aspects of the immune system over time. There are some hints to what might be going on, what might be helpful for the immune system, specifically as it relates to infectious disease. When people kind of cull all the data together, it seems like potentially what is happening is when people are sleeping, these key aspects of their adaptive immune system, like their B cells and their T cells, seem to be homing to their lymphoid organs.
And when you say homing to the lymphoid, tell me what that means.
Yeah. Of course. So what they find in these studies is that when people are sleeping, the number of these specific types of cells, like so B and T cells, for instance, drop, right? The number drops. And it's not that they are gone, it's that they've moved out of circulation and
Mm.
they are in, say, your lymph nodes or in your spleen or in your bone marrow. And when it comes to infectious illness and viruses, you really need your immune cells to be in the right place at the right time. And so the thinking around this is that that's what's happening. So sleep seems to play a role in ensuring that these types of immune cells are in the barracks waiting to jump into action. And as a consequence, that may play a better role in more rapidly clearing these potential insults. That's one way in which sleep may play this unique and important role. And I will say that the circadian rhythm plays a really important role in the fluctuation of these immune cells. But the studies where we employ sleep deprivation, we find that there are unique sleep effects, that it's not just due to ebbs and flows related to the circadian rhythm.
And do we know anything about neural hormonal processes and sleep? For example, we know that, of course, during sleep, levels of cortisol can drop significantly. We know that your fight or flight branch of the nervous system changes in its activity. Probably these two are more dominant during deep non-REM sleep versus REM sleep. Do any of those play a role? And is there any one stage of sleep that has been highlighted as important or even more important than the other?
That's exactly right. Sleep, obviously, as you mentioned, plays an active role in things like suppressing cortisol and catecholamines. So these canonical stress hormones that have already been shown to impact immunity. And, in studies where they've pharmacologically impacted those two aspects of the system, so the cortisol and in this case, epinephrine, it does seem to impact the ability for these cells to kind of move into these lymphoid tissues, which in turn may have impact on someone's immune health. Other aspects of these neurohormonal systems that seem important are sleep dependent hormones like aldosterone and growth hormone.
And when you
That
say they're sleep dependent, is it meaning that aldosterone, things like testosterone, etc., these are all things that are released expressly or preferentially in highest concentrations when we're sleeping, and therefore
right.
that's why you get an immune system benefit, because those types of steroid-based hormones are really requiring sleep, and the immune system requires those steroid hormones, and therefore the immune system requires sleep. Is that right, or am I wrong?
That is right. I think one of the challenges in talking about these relationships is it's honestly built on kind of a scarcity of evidence presently. There's kind of a handful of studies that have examined these things, but it is honestly one of these areas where we could do a much more thorough and rigorous job to understand how all of this works. It's obviously challenging to do in humans and the necessary experiments, but that is the idea. But again, there's a lot of job opportunity for anybody listening who wants to get into this space.
A partner and sponsor of today's podcast is Shopify. Let me share the link right away. Shopify.com/Matt Walker. As someone who spends his days researching sleep, the idea of selling merch felt, well, rather daunting. But I kept getting asked if I had t-shirts or gear. So I finally said, okay, Matt, get your act together and give it a try. And we have them coming. But the big question was, how on earth was someone like me, a scientist, going to get these items into your hands? Everyone said the same thing, use Shopify. It turns out, even me, an analog man in a digital world, was able to do it without any learning curve. Shopify is the commerce platform behind millions of businesses around the world and 10% of all e-commerce in the US. From household names like Mattel and Gymshark to brands just getting started. With hundreds of ready-to-use templates, you can build a really impressive online store that matches your brand style. Oh, and if you need artificial intelligence-powered help writing product descriptions or touching up images, Shopify's got that too. All of which is to say that if you're ready to sell, just try Shopify. So if you are interested, turn your business idea into reality with Shopify. Sign up for your $1 per month trial and start selling today at shopify.com/Matt Walker. Once more, that's shopify.com/Matt Walker.
And then, since we've spoken about sleep and the immune system itself, we've touched upon the idea of vaccination. And of course, vaccination has perhaps never been more salient in the public eye than in recent years. If people have gone down the path of vaccination, many people have for a number of disorders, including your flu shot and, of course, recently COVID. Is there a relationship in terms of my success of getting vaccinated? Meaning, yes, I can turn up. Yes, I get my jab into my arm. But that by itself does not mean a successful vaccination. In some ways, it's about how my body responds to the injection that I've just received in terms of determining the success of the vaccination. Yes, I've received it. It doesn't mean guaranteed it will be successful. Is sleep a factor that changes the likelihood that that vaccination will be successful for things like the flu or things like COVID?
This is the types of questions that we've been really trying to tackle. And vaccinations are a key model that we use. Before we get into the vaccination piece, the way that we got to that work was by actually exposing people to rhinovirus in the laboratory and trying to identify who gets sick and who doesn't.
Can you just give us the NPR version of that experiment? Because I teach this paper in my sleep class and I speak about it. It's a genius study. Tell me about it.
All this work originated from the Common Cold Unit in Britain, and they were doing these amazing studies there, trying to understand who gets sick and who doesn't. And then my colleague and one of my mentors in graduate school, Sheldon Cohen at Carnegie Mellon University, is just kind of world famous for doing these types of studies where they screen healthy people, have them fill out tons of questionnaires, and then bring them into the laboratory and expose them to known quantities of rhinovirus, and then basically quarantine them in a hotel in Pittsburgh, Pennsylvania, and wait sometimes 4 days, sometimes 6 days to see who in fact ends up developing what's considered a biologically verified cold. And so I was really fortunate that they had included wrist actigraphy, so kind of a souped up research grade Fitbit to give us an estimate of when people are sleeping and when they're not. And we tracked them for about a week prior to them going to the laboratory to get this rhinovirus exposure, with the idea that, and this is the way that I often think about this, is that it's likely that it's the people that have chronically short sleep or chronically poor sleep that are the ones that are at risk, this kind of wear and tear on the immune system. Then they're exposed to something and then it just doesn't go as well. And so we wanted to get an estimate of that. And so then they come into the laboratory, they get live known quantity of rhinovirus, and they stay in the hotel, and we track them over time. But we don't just rely on their self-report of like, I don't feel good today, or, those sorts of things. We actually had techniques to estimate against a true biologically verified cold. And the way that we did that was in 2 ways. Well, 3 ways. So first, we wanted to make sure people were infected. Interestingly, not everybody who gets the virus ends up becoming infected. And so we would do this nasal wash and then culture up the fluid to see if the virus was replicated in it. If they were, then it was considered infected. And then we wanted to track their mucus production. So we had research assistants collect the people's tissues throughout the day. And then at the end of the day, they would put them in a bag and then weigh the bag and subtract out the weight of the tissue in the bag. And that would give you kind of an objective measure of mucus that person produced that day.
You were bagging snot for the purpose of research, and the measurement technique was genius.
The research assistants were presumably were doing it for letters of recommendation. So they'll do what they need to do. And
highly valuable currency, it turns out, folks.
Exactly. And then the other thing that we did, it was an objective measure of nasal congestion. And so it was a mucociliary clearance time. What we had people do was each day they tipped their head back and we dropped a dye into their nose. And then we timed how long it took to get to the back of their throat. And so the longer it took, the more congested they were. And so because these studies have been done over time, again, including the Common Cold Unit, we had this metric for enough mucus or a long enough congestion. And so if people were infected and then met these metrics, they were considered to have this biologically verified cold. And so in the end, we do all of this work and it becomes this like yes, no outcome. Do you have a cold or do you not have a cold? And what we found when we looked at the sleep data was pretty astounding. I mean, I live and breathe this, but every time this happens, I'm just dumbfounded. What we found was this linear association with the people who slept the fewest hours being at significantly higher likelihood of having a biologically verified cold or having a common cold. And this is, again, everybody gets the virus. And, as an estimate of effect, basically people who slept fewer than 6 hours per night were about 4 times more likely to develop a cold compared to people who got the recommended amount of at least 7 hours per night. To me, it's really the strongest evidence that we have that sleep is implicated in the susceptibility to infectious illness. And importantly, because a lot of these studies have been done over time, we were able to statistically control all of the other factors that we already know put people at risk, right? So it's like over and above that, sleep plays this unique role. And then because other studies have been done over time, we were able to cull that data. It didn't have wrist actigraphy, kind of this more objective measure. But again, when we look at just self-reported one-item measures of sleep duration, we again see this like linear association between people who get the fewest amount of sleep are the ones at greatest risk when exposed to this virus.
So you're almost making yourself a dose-dependent model of sleep deprivation times infectious probability. The less that you're sleeping, higher the rates of infection. And if that's the case, if I'm not sleeping well leading into these seasons of infection, like the flu, I suppose that then does bring us on to that next question, which is I'm already laying myself vulnerable to the attack of these foreign agents that will make me profoundly unwell and sick. And then it comes time for me to say, well, I'm going to go and get my flu shot. If I'm under similar duress of insufficient sleep, am I not only more likely to catch the cold, am I more likely to essentially have a redundant needle jabbed into me because that vaccination that I'm going to receive is less effective? Because that seems to be what you were saying. That's the logical path. If you're more vulnerable to infection, on that basis, perhaps you should also be more resistant, as it were, to getting the benefits of vaccination.
Yeah. So after these cold studies, we wanted to really try to understand something a little bit more relevant to public health. Obviously, we can't continue bringing people into the lab to do these kind of very expensive things, but vaccination is obviously, to me, the next step because it really is this clinically relevant orchestrated immune response. And you're right. I mean, the concern is that, if people are not getting enough sleep, maybe their vaccine won't be as effective. I think the good news in all of this, and I want to underscore this, is that vaccines are incredibly effective. By and large, people are protected as a consequence of the vaccines that they receive. But there is some wiggle room in there. There's a variability both in how people respond, but I think also importantly, how long that response is maintained. There have been some kind of seminal studies done in the laboratory where they employ sleep restriction and then expose someone to, say, the influenza vaccine or the hepatitis B and A vaccine combined. And they do find that there may be as much as a 50% reduction in antibody responses, say 28 days later after the vaccine. So kind of 1 month after you get the vaccine, if you were deprived of sleep, it doesn't show quite the same level of response.
You weren't completely sleep deprived. Were you on a sort of a diet of insufficient sleep?
Thank you for correcting me. I did kind of mix those together. So the Spiegel study with Evan Cotter, it was a partial sleep deprivation study for several days, and the vaccine was in the middle of that period. There have been subsequent total sleep deprivation studies that also find this similar impact. And in some cases, people catch up over time, right? That their immune system is impaired and then it increases, and there is no clear difference between groups. In contrast, we have done this, but not in the laboratory. We've kind of gone out in the wild to understand predictors of vaccine response. And we find that, in fact, it actually does seem to potentially have a longer life of this difference. So an example would be, we did a study looking at the hepatitis B vaccination series. So this is the 3-shot series. And we were tracking people again with wrist actigraphy. So out in the world, giving them this watch, tracking their sleep to try to really, again, understand people that are more chronically short sleepers. Because we think that, again, this has a wear and tear on the immune system. And in this case, we did find that after people's second and third vaccine, when your body is beginning to really mount this and rapidly responds, that we do see this linear association again with shorter sleepers mounting fewer antibodies over time. To give an estimate, kind of for each additional hour of sleep that someone got, there was a 56% increase in the amount of antibodies that they had to this vaccine.
60 minutes of extra sleep, which many of us, in terms of losing it, will just think, oh, it's just an hour. What does it really matter? An hour can make a big difference, it sounds like. And here in the reverse direction, which is not losing an hour, but adding an hour gives you, did you say 56?
56%, yeah. And again, in this particular study, we couldn't then go out and expose people to hepatitis B, right? Like that's to see if if they're truly protected. But we do have CDC guidelines about how many antibodies someone needs to mount to be considered protected. The good news is most people were protected no matter what. But if you were a shorter sleeper, say sleeping fewer than 6 hours on average, there was nearly a 12 times more likely to fall in this unprotected group compared to people that slept more, at least 7 hours. Thankfully, many of us will not encounter the hepatitis B virus, but it does speak to the possibility that maybe people that are these shorter sleepers, like in addition to working on your sleep, which I'm a huge advocate for, but also maybe a need to get boosters. So it's clearly something that we see both in susceptibility to infectious illness on exposure, but also in this kind of fundamental public health domain in vaccinations.
Okay, time for some honesty. I've probably eaten more protein bars in my lifetime than I've actually blinked. They've been such a constant for me throughout my life. I recently found David protein bars, and it was my friend Dr. Peter Attia who raised awareness about David. He played a key role in the development of this really quite radical new protein bar. And just hearing it from Peter, knowing his standards, that's all I needed to at least consider making the switch. And then I read about the company. They are fantastic. The bars are built on a simple, groundbreaking concept: the fewest calories for the most amount of protein, period, ever. And each bar contains a wonderful 28 grams of protein at just 150 calories. They have 0 grams of sugar as well. That is the best protein to calorie ratio that has ever been seen in a protein bar. The taste, exceptional. I almost have to ration them. They're that good, because I could probably inhale about 10 of them in one go. Protein, of course, by the way, it's critical. It's not just for building and maintaining muscles. It's for managing metabolic health, helping you feel fuller for longer. And it's that unique ratio that I think makes David protein bars, just for me at least, the most satiating that I've also ever experienced. They are fantastic. They've got 6 incredible flavors. And here's a bonus: when you buy 4 cartons, you get a 5th entirely free. If protein bars are your thing, even if they're not your thing and you're considering them, just go on over to davidprotein.com/Matt Walker. That's davidprotein.com/Matt Walker. And you will get a wonderful experience in terms of that bonus. Okay, back to the show.
I do want to speak a little bit about COVID, and a discussion about sleep and the immune system would not be complete without that. But before getting there, you mentioned earlier on the state of inflammation that insufficient sleep produces. What role does inflammation play in this big tapestry of why insufficient sleep leads to a significantly less robust immune individual? Is the immune system one of the missing middlemen brokering the bad deal between insufficient sleep and inflammation, or is it something different?
I mean, inflammation is really fundamental to survival, to be able to mount this response and this communication. But it's often when it's unregulated. And it seems that when individuals have insufficient amounts of sleep or more sleep disturbances, when we measure these important biomarkers of inflammation, they seem to be at significantly higher levels compared to people that are better sleepers. And we also know that when people have elevated levels of inflammation, these pro-inflammatory cytokines that we can measure in the lab, they are at risk for a whole host of negative health outcomes. And inflammation has emerged as this key pathway and part and parcel of the immune system, but kind of a road towards lots of poor things that we already know occur at greater rates among people who don't sleep well. One of the key players in really culling this data together is this colleague at UCLA, Mike Irwin, who's really done incredible, careful study of how sleep deprivation can impact, say, even at the genomic level, the activation of these inflammatory pathways, but also put together a comprehensive meta-analysis showing that individuals, particularly if they're short sleep and then people who have more sleep disturbances, show significant elevations in interleukin 6, C-reactive protein, and to some extent, some of these other ones like TNF alpha and IL-1, though that's less clear. And that it is something that we really need to pay attention to when we think about the pathways that are related to health and sleep's role in those.
So moving from inflammation after vaccination, an infection, common cold, we should speak about the elephant in the room, which of course is COVID. And tell us what we were starting to learn, or maybe give us the core content. Has there been enough time and enough data for us to say anything about, firstly, A, COVID infection, and B, this notion of long COVID? Tell me about those two things, if we have enough data at all to speak to those two things.
It's one of these strange things, and it's hard to always go back and remember that time, right? That was a traumatic insult for the globe, but it was also this time to think about, gosh, this stuff that we've been doing, like it has so much relevance now. No one would listen. There's so much to talk about now.
Yeah.
And the irony of that. And there was first this, are there data to suggest that people who were the poor sleepers, were they the ones that ended up getting infected sooner or having more significant outcomes as a consequence? And one of the challenges with this, and as I was saying, the observational studies, is there's no way to control for exposure. It's really challenging. And so there have been a couple of large studies using hospital records that may suggest that people that were shorter sleepers or had insomnia might have been at greater risk for COVID severity or COVID hospitalization. There's a technique to use genetic markers, Mendelian randomization, which is a tool to help understand causal evidence. And so in kind of a large study using the UK Biobank, as well as the FinGen study, they were able to document this potential relationship. So that they just think like, oh, maybe at least people that are poor sleepers, they don't do as well if they do end up getting COVID. Our team had this really, when COVID happened, like we were obviously, everyone kind of buckled down, UCSF closed, but then we were able to gather some funding from the National Institute of Health when COVID vaccines were being rolled out. And, because we had this history of doing vaccine work, the whole university was closed, but we were able to commandeer the Pilates studio here down at the Mission Bay campus. And we turned it into this lab where we just started enrolling people before anybody had gotten vaccines to try to understand what might predict vaccine efficacy and maintenance. And the question was that we started with was, this is going to be happening, but not everyone's going to do well. And so how do we identify who's going to need, say, a follow-up vaccine, like, or a booster? And so the study was called Boost. It was this amazing time, Matt. I'd never in my career met people that were so excited to give back to science. At the time, people just wanted to contribute. Everyone was so excited about this vaccine rollout. Here in San Francisco, people were lining up in giant parking lots, waiting hours, and people just wanted to contribute to this. And so it was really exciting. But of course, we added all these sleep measures. We partnered with Aura to do objective assessment. And we're still culling through it, despite all these years later, we're still kind of working through it. But we do find that people who were poor sleepers, based on at least global questionnaire measures, tended to also not mount or maintain their neutralizing antibodies to the COVID-19 vaccines compared to people who are better sleepers.
It seems to be something common across all of these vaccinations.
Yeah, it's striking in that way. So we've done that. And then at the same time as we're dealing with this pandemic, people start reporting these long-term symptoms, right? This is long COVID. And it's become something that I've been really interested in. We'd known for a long time that there was these sort of sleep-related symptoms or fatigue that we thought was infectious, that people were exposed to something and it changed some of their physiology, their body chemistry, and all of these sorts of things. But we never had it at a scale that the people being exposed to the SARS-CoV-2 virus was. And so me and other colleagues that are interested in this space have begun to get more involved to try to understand what's going on with sleep in the context of long COVID, or what's also known as post-acute sequelae of SARS-CoV-2 infection, or PASC. The CDC would say that nearly 7% of the population experience these long COVID symptoms. So these are symptoms that go on for 3 months or more, or worsening post having a COVID infection. And there's a tapestry of different symptoms that people experience. Fatigue is certainly one of the most common, but there are dysautonomia, so difficulty in regulating your autonomic nervous system. But sleep problems, both sleeping too much and not being able to sleep, having kind of these insomnia symptoms, happen in about 40% of people. And so it really is something that we're trying to dig into. And thankfully, here at UCSF, we have an observational study where we're tracking these people, but we're also a site for what's called the Recover Project, which is the NIH initiative around long COVID. And just this week, we launched one of the clinical trials to try to see what we can do to improve people's sleep, both people that are in a hypersomnia state, so sleeping all the time, and people that are having what they call complex sleep disturbances, sort of insomnia, but also circadian rhythm changes that are impacting their ability during the day. And so we'll see what we can do, because, there's a lot of people suffering out there, and sleep does seem to be one of those levers that we might be able to push on to improve their daily lives.
It seems to be that sleep is to be thought of as a tool for supercharging our immune system, Is there any precedent in the field, any data that you know of, studies that you've conducted where people have really tried to proactively improve sleep through a variety of tools that has in turn then improved their immunity? We've spoken so much about this intimate relationship. That intimate relationship would make a prediction, which is use sleep as a tool. Can you use sleep as a tool? What's the evidence? How have people done that if they have?
It's definitely the next frontier of this kind of work. I completely agree. How many more times do we need to show that, when people
Yeah.
aren't sleeping well, this thing happens? The question is like, what can we do to improve the lives and actually create that semi-causal path? There have been a handful of studies that have done this. It's mostly been in the context of people that have insomnia, and the outcomes have been inflammation. That is basically where we've looked. And so again, this is work, a lot of it's been done at UCLA in Mike Irwin's group, who I mentioned earlier, where they do find in some studies that when, say, older adults who are randomized to get cognitive behavioral therapy for insomnia, so kind of this gold standard treatment to improve insomnia through non-pharmacologic means, compared to a sleep hygiene control, they can and have seen related reductions in both circulating levels of markers of inflammation, so maybe IL-6 or TNF alpha, but also at the genomic level. So the machinery that is read to then drive these protein changes is quieted. So the gene expression is downregulated, which suggests that there may be something there. Now, I think there are a lot of opportunities to do this in a variety of different ways. I mean, I think there's still like a lot of outstanding questions around sleep and the immune system in general. We don't have enough studies actually trying to understand what is going on and what are the drivers of these changes in the immune system. And so I do think there are places for the experimental work, despite the fact that I just said that the next frontier should be interventions. But I also think that there are a lot of clinical settings where we already know the immune system is impaired and they also have sleep problems. And so could it be that we could directly intervene on these sleep problems to try to improve the health and well-being of these individuals that are already in a susceptible state? Rheumatoid arthritis is one of these ones around inflammation. I'm collaborating with some folks in the context of transplant, like organ transplant, where the immune system is critical in keeping people going, but their sleep is also incredibly disrupted. And so
Yeah.
can we use these clear tools that we have to get under the skin and bolster up someone's immune system so that they can survive and thrive? I think it would be an amazing area for anyone who's interested in a career in research to embark on.
It's incredible too to think that often the one place where you need your immune system the most, where there is also probably perhaps a higher risk of infection, is the one place where you typically sleep worst, which is the hospital. And we could perhaps do so much to the hospital environment. And I think sometimes I go on a long haul flight, economy class, and I still get a free eye mask and a free pair of earplugs. Why don't we just give out something as simple as that? The pennies on the dollar, but could we try to at least augment even just 20, 30 minutes more sleep? You were talking about 1 hour of additional sleep causing changes in immune function, double digits in terms of percentages. So I'm sure I'm hoisting a flag that you may salute, but Aric, I want to bring this to a close. On behalf of everyone listening, thank you for these insights. And more specifically, where can people find you if they want to learn more about your work, what you're doing? You have some great public outreach. I know there's great video content of you out there online. Where should people go to connect with you more?
Certainly, you can find me on social media, on X. I think it's at Aric Prather. I think I have a poorly designed website, aricprather.com. But also, I'm at UCSF. I'm pretty findable. So as long as you spell my name correctly, you'll get to me. So it's AricPrather. Yeah, I'd love to connect. Anybody's interested.
Thank you so much for being on the show. Folks, please go and follow this wonderful gentleman. And with that, I will sign off. We will both wish you a resplendent night of sleep. Aric, thank you once again.
Thank you.